all you did? This is all you were up to for your trip, or did you go buy Motivo and stuff too?
Was that? No, I met with Swift Engineering at 7 o'clock in the morning. A younger guy. Yeah. Yeah. No, he now retired.
All right, everyone, find your seats. Train's leaving the station here. All right, welcome everybody to this amazing venue, the Lions Automobilia Museum. My name is Chris Bachman. I'm the chair of the Society of Automotive Engineers in Southern California. I'm also, when I'm not working with the Society of Automotive Engineers, I'm the chair of the Mechanical Engineering Department at Cal State LA. So we'll have a few announcements related to that later on. Can I get a little whoop whoop from my Cal State LA fans over here? We got 2 or 3 of them in the house today. All right, so we'll talk. I want to talk a little bit about our section first, but as a professor, I can't help myself. I have to start off with a little bit of a quiz. What do all of these pictures have in common, or all of the items in the pictures have in common? Yeah, built right here in Southern California. One of my favorites, of course, being a Zamboni. So if anybody likes to talk ice hockey, that's me. There's also, you can see the Monarch tractor coming out of Spin Out Motivo. Alan, the CEO, here in front as well. But so this event is put on by the Society of Automotive Engineers. Emily will be moderating the speakers today, as well as John Steiner. So thank you to all of you and for what you do. And if people are interested in getting involved, I'll have my email up here. We're definitely looking for more people who like to put on events like this, and especially people in the aerospace industry. We're chock full of gearheads, so we could use a little variety in the group. So another big reason why we need more people is that we have nearly 40 student teams here in Southern California working on projects. And we try and provide them with everything they need to be the best at these competitions. And so we need people to help interact with those universities and provide them advising and guidance. And so yeah. So shout out to CSU Fullerton. You're always here repping in Big Supply. So thank you. But yeah. So if you want to help get involved with these student teams, come and see me afterwards. So we've had a pretty successful six months. We've had 15 events in these last 6 months. We usually host an event here every month. In addition to that, we put on 2 big student events in the fall and spring. And we just got back from an event this Saturday at the Industry Motor Speedway. So shout out to Cal State LA. We record almost all of them and put them up on our YouTube page. So please follow us on YouTube, and if you want to go and check out all the videos that we have from all these and then we'll also have a couple of other speakers here, and so definitely come check out our upcoming events. So here's a little bit of an intro for this mid-air barrel rolls, as well as we just figured out, so I don't know if the student teams even know this, but we have there's going to be at Willow Springs an event this fall for all of the formula teams. So they just put this up. So I'm sure they're going to be looking for volunteers, as well as SAE has 2 upcoming conferences in the area. So one on brakes and one on onboard diagnostics. Question?
Yeah. So for a school that doesn't have a car, are you still allowed to go? Or we don't know.
Yeah, we've asked headquarters about this. I would presume that like you're probably there's going to be some ability to go in and see them, and we're going to definitely push. I think they're going to, yeah, we'll talk more afterwards. So it's not certain, but we're going to be pushing for that. So with this, I want to first say thank you to our wonderful hosts here. So I'm going to bring Dean up, and you want to do the introduction?
Yeah, Lana, you want to come up and say a few words about the museum? This is an amazing venue, and the room in the back can accommodate 700 people. So I will give the plug for it. If you're looking to do a corporate event, do not rent a Hilton ballroom. Rent this place. It's so much cool.
Coming here tonight and enjoying our museum. This was a dream of Rick Lorenzen. This was his vision. His goals was to bring young people and let them understand what he fell in love with, which was hot rodding and drag racing and just motorsports in general. So if we lost him, almost 2 years ago now, but he would have loved being here tonight, being with the young engineers and learning about that and just being with everybody here and sharing his museum. So really grateful that you guys are here tonight and joining us. And I'm really excited hearing about the F1 engineers because I love your TV show over there. So it's been awesome. So, thank you for being here tonight. Like Dean said, we're available here for doing venues for any sizes from 10 to 700 people. And we also have an incredible education program here. We just recently hosted a Real Deal Revolution with a welding class. So we had an 8-year-old and a 10-year-old learning how to TIG weld. So it's pretty exciting. That's what our goal is, to bring young people into our industries, like these two gentlemen over here. So thank you for coming here tonight. Thank you.
So, if you notice, when we have the RSVPs, it goes through the museum because SAE, we're not trying to make money on any of our events. We're just trying to not lose money. Break even, but all the proceeds from these events go directly to support the nonprofit museum. We've teamed up with several groups in recent years. One of them is a brand new group in Southern California, Women in Motorsports North America. We had an even larger group here in April prior to the Acura Grand Prix of Long Beach. So Meredith, you want to talk about WIMNA?
Sure, I'll be happy to. Hi, my name is Meredith Burns. I'm the chapter president for WIMNA, so that would be the Southern California chapter. And we have several chapters across, and our motto is advance, connect, and enable. And so that would be helping women find careers in motorsports, pursue careers in motorsports, and help them. We do that with our Women with Drive Summit, which is coming up in Indianapolis, December 7th through the 9th. And those who are members get a $50 discount on attending. And anyone who is interested in finding out more about the organization, you can see me. I'll be in the back with some literature. And also, fun fact, the September Kansas race for NASCAR, all of the WIMNA members, their names will be on the hood of Daniel Suarez's car. So if you want your name on his car, go ahead and sign up by August 13th. And your name will be on there. So thank you everyone for being out here tonight.
And we should note, while it's called Women in Motorsports North America, men are allowed to join. So how many people out here are journalists or in the PR field, automotive? How many of you are members of MPG? If you're not, you should be. So Dave Bolt, you want to come up and say a few words about Motor Press Guild?
Thank you, Dean. Actually, Dean, you said what I was going to say, so should I? Anyway, my name is David Bolt. I am the transitional president for the Motor Press Guild, 1 year and one and done, as it were. But what I wanted to tell you, those of you that didn't raise your hand, there's an opportunity to expand your portfolio, both personally and professionally, by finding an outlet or creating an outlet and reporting on what it is you did at the beginning of the last century. But I was and am paying attention to what happens at the beginning of this one. And there is not a more exciting time in the automotive sphere than there is right now. So if you've got a gig that provides you access to some of the interesting stories that are being written, the narratives, and want to expand on that, whether it's with an existing outlet or one perhaps that you create yourself, we'd like to talk to you. We're not a startup. We don't have anything sexy in that regard, but we are a restart of an organization that's been in Southern California for something like half a century. And what we're doing right now is plugging in with the greatest degree of energy possible in all that is motoring in the California automotive culture. You need only walk around here to have a glimpse of what that constitutes. We'd like to see you reporting on it, writing about it, and we'd like to see you as a member of the Motor Press Guild, possibly while I'm still there. But thank you for your time. Appreciate it.
Thank you. And then we're doing something new we wanted to do for a long time, but we finally got a little bit of a critical mass. Since the industry is changing so much and a lot of people are looking for new career opportunities, we want to offer any company in the automotive space who would like to, is that your phone? Okay, not sure. Okay. We'd like any company who's looking to hire anything engineering related or automotive related, 1 minute to give a pitch for what your company's looking for, so you can bypass the dreaded HR filters and actually get to someone who is empowered to say yes. So Dr. Bachman, you want to talk about what Cal State LA?
Yeah, so that means you have a lot of mechanical engineers these days, a lot more than you've had previously, which for the chair is a good problem to have, but it does mean we are looking for a lot of lecturer faculty. So if people are interested in giving teaching a shot or have some experience in teaching, we're looking for people with masters and PhDs who are interested to teach numerical methods, some of our statistics, some of our math, and yeah, a lot of our kind of computational courses. So my email is the section.chair@saesocal.org. Cal State LA Place is an amazing place to teach. The students are great. They're there to learn. They're hardworking. They ask great questions. So yeah, if you're interested, send me an email or find me after the talks.
Okay, and I didn't even get Jeff's name within the sport in the industry. Edelbrock still has a presence here in California and elsewhere. So
very much elsewhere. Thanks. My name is Jeff Cragness. I'm Director of Engineering and Product Development at Edelbrock Group. Sorry. We are, we do have our foundry is in San Jacinto, California. So we cast our intake manifold, superchargers, cylinder heads. We do some machining there as well. We're always looking for foundry engineers. I don't know if anyone's got experience either coming out of school, or even senior level. We are currently headquartered in Little Branch, Mississippi. We've got manufacturing in North Carolina, in Tennessee, Michigan. So we're kind of all over. So, probably the easiest way to get in touch with us is, go through our website, careers@edelbrock.com. And we can, see if we can find a place for people. My past is 30 years ago. I was Cal Poly Pomona, Mini Baja SAE. So, SAE does lead you a lot of places. So, please reach out to us, and, good luck to all you guys finishing up your school careers.
Kurt, you want to come up and talk Myers-Manx?
Thanks, Dean. Sorry, a little too far away. Hi, everyone. My name is Kurt Horner. I'm the Vice President of Engineering for Myers-Manx. For those of you that may not recognize the name, it's the classic dune buggy company from the 60s. I joined Myers-Manx around 3 years ago, and we've been reintroducing Myers-Manx to the world as all-electric dune buggy that also can satisfy replica car targets. We're now branching into maybe the next generation of where we're taking the company. And so I'm going to continue to grow the team. And so I talked to Dean and asked if I could kind of PR that I need to grow the team a bit from where we are. I have roles that are mostly on the senior level. I need people that have some experience in a field. So 5 to 15 years is probably ideal. 5 to 30 is great. It depends. We're such a small team. It might be hard for someone right out of school just because we don't have any infrastructure for teaching young grads. But in any case, I'll make sure my email is addressable somehow, and I'll be around after. So feel free to come up to me and say hi. And also check out our website. It's pretty cool what we're working on. And the next generation is going to be even cooler. So anyway, thanks.
30 seconds.
Oh my goodness, that's way too time. Motivo came out of the racing industry. You all know every race thing out there has rules. And the only way you get a competitive advantage is you come up with bleeding edge technology that's not covered in the rules. And you get one season. You either caught up or they outlaw you, right? Motivo came from that environment. We are a bleeding edge hard tech engineering company that is working on prototypes, usually 7 to 10 years before the public finds out what we did. And we're working on everything from eVTOLs, electric vertical takeoff and landing air taxis, to full build electric autonomous vehicles, to industry we've done in our past as well, and everything else in between. So if you're really excited about bleeding edge technology, doing something nobody's ever done, but doing something that's going to make the world a much better place, we're the place for you. And we've got several Motivans in the audience. Raise your hands. Find them. Let them know you're interested. Some of you didn't raise your hands. But find them. We have internships all the way from high school all the way through college, and then we're looking for the best and the brightest. And you know, the cool thing is, when you're working in bleeding edge technology, you're going to make a lot of mistakes. That's how you learn. But some of those mistakes come into the revolution.
We'll post all those links onto the SAE SoCal LinkedIn page. And I'm assuming that probably every one of you, even if you're not interested in any of those positions, you know somebody who's qualified for them. And we'd like to have more companies come and do this on a regular basis, particularly on the aerospace side. There's a huge amount of aerospace history in Southern California and a lot of brand new startups in the Long Beach area. So we'd like to take advantage of that. But I'm going to turn over a minute here to Emily Sharp, who's going to moderate. But a little bit of history. For those of you who don't know, Long Beach used to be Formula One. 1976 to 1983, it was a Formula One race in Long Beach. And in 1981, Williams won. It was top two. And my funny oddball story was I was in high school in 1980, and my job was doing landscaping. And he owed my boss money. So we go over to the Long Beach Grand Prix on Friday morning, had lunch or breakfast with Alan Jones Friday morning before the race. And Alan gave my boss a check and said, "You guys have tickets for the race?" And it's like, "No, I figure we'll just buy general admission passes." He goes, "Well, here, just use my pass." So we had the defending world champions FOCA pass. And my boss was in a wheelchair, so I had to assist him. So we got two of us in on one pass. We go to the garage to find Alan to return it. He wasn't there. So we walk up to Frank Williams and said, "Can you give this back to Alan?" And he looked at it, "How the hell do you have this pass?" But, you know, back in that era, I mean, Formula One, before the internet, you would read Road and Track and Car and Driver and other things. And those of you who are familiar with Willow Springs, you know the track there, there's Big Willow and Willow. Streets is named because that was a test course for Long Beach. And so the Formula One teams used to test at Willow Springs. So it was a big deal back then. So it was great. You know, someone asked me, how did I talk Williams into sending two engineers over there? I didn't. I just happened to know two really cool Southern California guys, and I knew they had to come home. They don't let them work in August for these weird rules in Formula One. So I said, "Would you give us an evening of your vacation to come and talk?" And they both graciously agreed. So that I want to turn it over to Emily. She'll introduce them, and I think they got a few slides they're going to show each, talk about the career path. Then Emily is going to grill them. I mean, that's nice, fun questions, and then allow for questions from the audience. So take it away, Emily.
Thanks, Dean. For anyone that knows Dean, he's famously known as the most well-connected man in motorsports, and so sports. Before we get started, I do want to just acknowledge the incredible Lions Museum again. Thank you all for joining us, all of the WIMNA members in the room, all of the SAE SoCal members and alum, and all of the students joining us tonight, and everyone joining us on the live stream from home. I'm thrilled to introduce our guests tonight. First, joining us is going to be Prescott Campbell. Prescott is a Newport Beach native and currently works as a graduate structural engineer with the Williams F1 team. He recently graduated from Oxford Brookes in the university and in the United Kingdom, and with a degree in motorsports engineering, where he led the Oxford Brookes Racing's Formula Student EV team. And those of you who know, that is a huge deal. It's one of the largest and most successful Formula Student teams in the world. Before moving into engineering, however, Prescott was also a racer himself. He won the 2019 Lucas Oil Formula Car Championship and earned a scholarship opportunity to compete in IndyCar's junior Formula pathway before transitioning his focus from the cockpit to the engineering side. Welcome, Prescott. And joining him tonight is going to be Rami Edirisinghe. Names are important. I'm thrilled. Excuse me. Rami is a South Bay native who currently works at Williams Racing in the system simulation department, focusing on powertrain cooling and mechanical system simulation. His path to F1, however, is a great example of how careers in motorsport aren't always linear. After studying at Georgia Tech, working as an R&D engineer at Advanced Clutch Technology, and volunteering with grassroots racing programs, he later earned his master's degree at Cal State Fullerton. Go Titans. Where he specialized in thermal fluids. Rami then followed by making his way into the Williams F1 team. Welcome, Rami. And Rami, before you sit down, I'd actually like to pass the floor to you and go ahead and lead us through your journey.
Thanks, Emily. All right, so a bit about myself. Always been crazy about cars, and my 1975 BMW 2002, which two of my friends who are here will definitely know. I've somehow roped them into helping me every summer with it. So here's to friends. But I've had this car since I was 16, and I've decided to do a very sacrilegious thing and replace the BMW engine with a Honda K24. So you can see that right there. So yeah, very polarizing. One of my colleagues in powertrain integration, he looked at me, he's like, Rami, like, I really like this car project of yours, but why did you have to put a Honda engine in it? Like, so to each their own. So yes, but this describes me. I love just swapping in random engines into random cars. I felt that BMW 2002 always had to have a 4-cylinder. So there you go. So my motorsports journey started at Georgia Tech. I did not do Formula SAE as an undergrad, and I think this goes that F1 teams in general are just looking for good engineers. So at Georgia Tech, you could do Formula SAE, you could do Baja, you could do Aero, or you could do rec racing. So rec racing is part of the Grassroots Motorsports Challenge. So you get $2,000. You can do practically anything you want with some safety guidelines, but the $2,000 limit is a hard cap. What budget? So with this championship, this was in 2010. A lot of engineering on this car, but on this power plant wise, this has a Lexus 1U ZFE. And then we wanted a manual transmission. We couldn't afford it, so we thought, what could we do? We ended up building a microcontroller that basically shifted the automatic transmission. Because the grassroots race only is an autocross, and you only use second and third gear, followed by a drag race. This worked for us. So then my last year of Georgia Tech, I was the lead engineer. So this was my my creation. So this is an MG Midget, and if you look very carefully, you can see a 2JZ in there. And if you can imagine, a 2JZ was ever meant to go into a small 60s British car. So needless to say, there's a lot of chopping required. The front suspension is hard to see in this photo, but that's a first generation Mazda Miata suspension with Suzuki Hayabusa shocks. there are a lot of really cool little engineering tidbits on this car, but my favorite one, or one of my favorite ones, is this drive shaft right here. So as you can see, it's quite small because after you put the engine and then the GM transmission and the Ford 8.8, there's actually not a lot of room in between them. But the biggest issue we ran into was, at this point, I think we had $50 left in the budget, and we had to somehow shorten a drive shaft and balance it. So we were trying to figure out how we're going to do this on $50. And then we realized that and the Ford side was 2.75 inches in diameters, and we came up with this idea of building concentric rings, using that to center the thing and then welding it. So that actually managed to work for us. But this is the thing about, like, a good engineer knows how to look at problems, and it's not necessarily always about what simulation tools you know and like what kind of problems that you're looking at. It's more, well, rather, it's more about how you look at your problems and how you approach your problems and how you go back to your fundamentals. And this is one thing I really learned a lot. But the other heartbreaking thing you learn is that motorsports can be quite cruel. So as you can see at the end, we spent all this time building this amazing car. We have half the team out there at the competition. And then we're doing our final, just set down check. And then the rear axle mount decides to fail, taking the transmission out with it. So that's motorsports. Get used to it. So what we ended up doing was we just switched power plants. And so you have our team pulling the car through the autocross and through the drag. So oddly enough, the person in the corner is a startup founder, so he learned a lot of resilience from this thing that he will use later on in life. Yeah, so effectively, we did not DNF. We were the slowest team, but we won spirit of the event. So I think that's another great thing about motorsports. You can work really hard, you can have the best ideas, but sometimes you will not win, but you keep on trying. By the way. Okay, so past Georgia Tech. I was working in ACT, and I was kind of missing that motorsports itch. So what do? Well, enter Mark Yeager. So Mark Yeager was a time attack switch from a common sense engineering or structured scientific approach on how you do things. So this is where I joined. I sent Mark an email, said, hey, I'm just looking to volunteer for some more sports opportunities. I work at ACT, I work ClickSpy. I have experience in these different areas. And I also am interested in aero. And for some reason, all he saw was aero. And then I became the aero guy. So, so this is what aero guy looks like in 4 years. So top right corner, top left corner, this is how we started. We borrowed someone's car and basically did pressure measurements on the hood. So during that time, I didn't have access to CFD, and I couldn't do the perfect test, so kind of size our cooling system. Then from there, we had a couple arguments of I can't keep on using mechanical pressure sensors, I need real data logging, and happened to come into a time where AEM came out with their data logging equipment. So we sent them a sponsorship request and said, hey, we want to start looking into data logging. Could we work something out? And so we started a technical partnership with them, and basically we added data logging into the car. We started doing a lot of experiments. So on the bottom, you'll see this is one of my instructions for an aero test. So this is Big Willow. So Willow Springs means a lot to me because I did a lot of events there. But here, I'm setting up for what's called constant speed running and looking at how the pressures on the car change at a constant speed. And then we can use that for correlation and design of a car. At Cal State Fullerton. And so Jaeger Racing kind of leads me into Cal State Fullerton, which I'll show next. And then it ended up with an event, an article on Moto IQ, just talking about how we use data to develop a car. So it was a really great learning experience. And honestly, I did not know how this was going to lead into the professional motorsports world, but it gave me the grounding that took me there. So Cal State Fullerton, and this is a lesson of problems can sometimes become rabbit holes, and you need to know when to stop. So what I was really interested in was in ground effect tunnel cars, and in order to study these properly in wind tunnels, you need to have something called a rolling road, which on the surface looks like a big truck. Looking into building this rolling road apparatus at Cal State Fullerton, And this is kind of from a talk I did a while back, but there's various subsystems on there. So there's one that makes sure the belt's aligned all the time. But the big one is the cooling system, because what ends up happening is as your car gets closer and closer to the ground, the pressure reduces, and then what happens to your belt is they get sucked up to the bottom of your car, and then that ruins your experiment. So then you actually have to add a vacuum to bring the belt back down. But when you do that, then you start heating up the plate, and then you had to cool the plate. So it's just like this really big problem. And so ended up, okay, how do I solve this problem that I was not anticipating? And why am I not doing aero yet? So again, as I said, this could become a huge rabbit hole. This is about a couple years worth of master's work. So I started with just going back for the fundamentals, like very basics, first principles. Okay, how can I model this? How can I look at how heat transfer coefficients affect the cooling? And then I go deeper and deeper as you go to the right. So this is like a model in the I have, and then on the bottom, this is looking at the airflow distribution through the cooling plenum. And then on the far right is looking at the facility-wide, so looking at the effect of how the rolling road will affect the environment of the wind tunnel itself. So a lot of things, and I still don't understand how this is going to get me into Formula One, but it was an interesting problem, so I was working on it anyways. So then I graduate, and I'm applying to aero jobs because I knew I wanted to be an aerodynamicist, or so I thought, and I wasn't really getting very far. And then I applied to an aero role at Williams, and then to my surprise, the HR comes back to me and says, you know, Rami, like, you're not really qualified for this aero role, but we see you have all this heat transfer experience. And I was like, yes. And they were saying like, well, we're actually looking for a heat transfer person. So that just, I didn't even know you could do heat transfer in F1. Like, I mean, it's probably obvious, but like, I just was so hard focused on aero that like, I never thought that heat transfer could be a thing. And like, so that's how I got into F1. So I had to thank the rolling road for that, but yeah, know when to stop problems. So what is system simulation? This is the group I'm working with. And so when you build a race car, you often have trades. Like you can make the best cooling system ever, so you can reject the most amount of heat. You can make the best aero possible, the most downforce, least drag, or you can make the lightest car possible. But if you optimize for just each one of those things, you won't get the fastest car. The fastest car is the one knows which trade is the best to make. And that sometimes varies from track to track. So that's what our group is about. And I kind of made this tacky thing, which I like that they put Nigel Mansell as the highest power output, but Ayrton Senna, yeah, maybe best aero performance. But the idea is that in a cooling system, we have to make these trades. We have to think, okay, do we size our cooling system so that we can extract the most horsepower out of what Mercedes can get out of the engine? Or do we size it so that we have the least amount of drag? Or do we size it so that we have the best mechanical grip, so least amount of weight? So that trade is something we always think about. And that's just the cooling system, but there are many other systems on the car. So you can think of, like, say, nowadays, the DRS system. How do we size that? Or a really interesting one is suspension. So aero and suspension are highly coupled, especially in the previous generation. So if you just optimize for your ground clearance, but you don't think about your suspension, then you can have a car that's got a porpoise a lot. And so that is another thing that system simulation looks at. Like, how do we look at the car as a system and big picture wise, and then help aero, help mechanical design, help all these other people, you know, build a better car. So I think I've been talking a lot. So now I'm going to hand it over to Prescott.
Hey guys, just going to run through my background and my path to Formula One. So I will start, is it this button? Yeah. I'll start before university, my high school days. So I studied high school at Corona Del Mar High School. And there I got involved in FIRST Robotics. I was very fortunate at a young age to know exactly where I wanted to end up in my career. I had a dream, I had a goal. Both my parents were engineers, so I was naturally interested in it from them. And I loved motorsport, thanks to my dad. So I knew I wanted to get to Formula One as an engineer of some kind. And because of that, I could think very early on from when I was about 14 years old to think about, okay, I know it's going to be very competitive to get that job when I'm in the position to apply for them. How do I start right now to get some advantage over all the other candidates that nobody's going to even be able to prevent that from happening? So First Robotics was really the first opportunity for me to start building that repertoire and that experience. And I was lucky that there was a program that had just started at my high school in my sophomore year. So I got in there, and as a sophomore, which was our team's first year, became the CAD lead because I was the one willing to learn how to use SolidWorks. And then also at the same time, I was racing go-karts and really doing it because I enjoyed it and I was learning a lot and it was challenging and I love competitive sport. But at the time, really never realistically thought I could ever have a chance at a career as a driver. And I loved engineering. So also before university, I had an opportunity to work at a company called Airwolf 3D. And this was a local that made 3D printers in Fountain Valley. And you know, it's an unpaid internship, and they had a plan to take a Dodge Hellcat to SEMA and CES 2017, 2018 during that trade show season. And what better way to appeal to small automotive businesses who were too scared to dip their foot into 3D printing at the time than show them that a 16-year-old can make parts for a real car that goes on display. So I spent my summer and the beginning of my junior year designing custom placement parts in the interior of this Hellcat. And that was a great experience. Did video, made videos that are on YouTube if you guys want to watch it, and everything I was learning as a 16-year-old, getting to grips with engineering. And then to SEMA in 2017 and getting to present and speak to all these business owners and employees and trying to prove to them that 3D printing is a rapid iterative prototyping process that they can all benefit from, and it's something that's really accessible. So that was a great experience. And yeah, it was nice to get that at such a young age in high school. And then it was coming time to apply to university, and I was trying to decide where to go to give myself the best chance to get in Formula One as an engineer. And I had heard a story of a student from Northern California named Trevor Green Smith, who had gone to a university called Oxford Brookes University in the United Kingdom. And he had gone there and then managed to come back and work as a performance engineer at Dalecoin Racing. So I'd heard his story, I reached out to him, and I really just wanted help deciding, is going all the way to the UK for something like this really worth it? Is that going to give me the best chance? And I managed to secure, again, an unpaid internship for the 2 weeks leading to the Indy 500 at Dalecoin Racing on Santino Ferrucci's car, the 19 car. He was a rookie at the time, and doing anything I could to help out this team. As you guys, any IndyCar followers will know that Dalecoin is a pretty low-funded team, very much an undersized team compared to all the powerhouses like Penske, Andretti, Chip Ganassi, etc. And so I was doing everything I could to help manage radios throughout the weeks. I built like a 3D printed little driver cooling fan system to keep the drivers cool on the grid and in the pits when they're giving feedback. And then I was also the dead man, was the role they gave me in all the practice, which is essentially the person that activates the fuel hose to fuel in the car behind the pit wall. You can all think about why I might be called that. And then during the race, I was very close to being assigned throwing the tire over the wall to the tire changer before they realized that's probably not give to a scrawny kid who doesn't fit into any of our fire suits, who also have never done this before at the Indy 500. And so my role that morning of the race switched to being the lollipop man. And that was awesome to just be involved in the pit stops in that race. Santino went on to finish 8th that year, and he was the top rookie, and that was super rewarding. And yeah, that was a great experience. But the main thing that I benefited over those 2 weeks was speaking to all the engineers in the paddock, just finding a way to get into that paddock and go and just walk up to all the different teams and speak to the different engineers there and ask them their opinion of what university they thought was best for me to study in was so valuable and really just convinced me that Brookes was the place to go. There are people that I had met that were in different teams that had studied there, people that wished they had studied there, and they're all telling me that I should go there. So made the decision very clear, and later that year, I applied to Oxford Brookes and thankfully got into the program. So our first year going from combustion to electric, guys that are involved in FSAE who have been part of that transition know how difficult that is. One thing that was a challenge was we went from combustion rear-wheel drive to straight to in-hub motors, all-wheel drive electric. And at a university that doesn't have an electrical engineering program. And so none of us knew what we were getting into. And we all had to be self-taught. I didn't get involved into the electrical sections right away. I was very much determined to get into the mechanical side of engineering, but it was a challenge. And you want to do everything you could on the mechanical side to make sure reliability didn't get in the way of preventing learning track time with electrical systems on the car, which is really where the challenge was going to getting that car working. And yeah, that was a daunting experience. But at the same time, like I said before, I never thought I'd have a chance really realistically at a career as a driver. But Cooper Tires hosted an inaugural scholarship shootout at the end of in the middle of my senior year, where kart drivers could apply, they could get in. They had a 3-day judged event at Sebring in their race cars, which are very similar to Formula Ford's 4-cylinder wingless 2-frame chassis with treaded tires. And yeah, I went there not really having any expectations for myself and ended up winning the thing. So that gave me a full season in cars starting at the end of my senior year, not really knowing what to expect. I was also racing the professional level of shifter karting in the US that year too, in 2019. Had a bad accident, flew out of a go-kart, broke my femur, missed a few car races, but then got back in the race car and podiumed and won every single race that I could finish for the rest of the year and managed to win the championship by a few points in the last race. So that was awesome. Very rewarding experience. Really good lesson in never giving up. And sometimes I question whether breaking my leg was really what allowed me to win that championship that year. And if I'd never done it, never had that additional challenge to overcome, if I would have ever been able to become the driver I did by the end of that year. So that was a great experience, but it also meant I was expecting to kind of go to university and focus on an engineering path. And all of a sudden I had this scholarship to race cars in the United States. So I did the natural thing and I decided to commute between the UK and the US every week, every 2 weeks to test a car and race a car to get ready for the US F2000 season that year. And yeah, so it was 2020. I signed a contract to get my first US F2000 season, and I was in Florida around beginning of March time. Left the UK fully expecting to go back in a couple of weeks after preseason testing in the first rounds at St. Pete. Little did we know that COVID would become global in those few weeks. And so I went to Florida. We did all the preseason testing, top preseason testing. That was awesome. Got to St. Pete, did the practice day, getting strapped in for qualifying, waiting for 30 minutes for the green flag to get thrown, get told to get out of the cars. And we're going to pause and delay the schedule until the next day. We were kind of like, okay, is it COVID related? Not really sure. IndyCar wanted time to decide what to do. Next morning, okay, compressed schedule, no fans allowed into the circuit grounds. I'm just going to have a private event with just employees and everyone that's needed to hold the event, make it run. No fans. Get into the cars again for a very early qualifying session that morning on a Saturday. Waited in the car again, waiting for the green flag to fly, get told by the engineer, get out of the car. Everyone has Twitter open on their phones. IndyCar just canceled the event. So that was pretty interesting. And then my flights got canceled, going back to London. So that was awesome. Went back home to California and didn't end up going back to the UK for a year and a half. So I ended up, continuing racing when that season got rescheduled. And when it came to the beginning of starting my second year of university, it was all remote. The time difference was not ideal. At the same time, something that's unique to UK, studying in the UK, particularly engineering, is that companies, the way they have internships are 1 year long placements, is what they call them. And all those applications open right at the beginning of the academic year, and they weren't there. There were no F1 teams offering positions. And I knew from all the alumni at Brookes that I knew at that point that majority of them got into Formula One as a graduate because they just hope for something to change or defer a year and hope that COVID has relaxed a bit. People have become financially more confident in hiring new positions. So that's what I did. So I withdrew from university for the year and ended up racing for those 2 seasons in the USF 2000. And I also found an engineering job here in Southern California in El Segundo at a company called Fluid Logic. Some of you may be familiar. They provide hydration systems to IndyCar teams, endurance teams, IMSA teams, and Baja teams. And so I was there. I started just soldering cables for them. My record was 19 cables in one day. And this was the button that the drivers could press. And I was just really eager to get some real engineering experience. And so I basically just started trying to use the 3D printer that they had on site to prove to them that I could start making something that was useful to the company. And ended up prototyping the insulated canisters that you can see there and the lid technology to allow that to feed into their system. And all of a sudden they could sell a complete package from the housing of the water, the pump, and then the driver's button. But it also meant that this company had a product that didn't involve silicone chip in it that they could sell for profit during the time of the silicone shortage during the COVID years. And so that was really rewarding. Got a product from prototype into a race car, into the LMP3 car there at Thermal within 2 weeks. And then that was actually the first one that we sold. And then got to learn a lot about injection molding, trying to mass produce the same sort of thing. And yeah, it was just a great experience and really helped me gain even more experience when it came time to applying to those placement years, which did open up as applications when I went back to university. So I applied to placements. Williams was the first one to open with opportunities. And I applied. They were the first ones to interview. I interviewed for 3 positions: composite design, design of the wind tunnel model, and then structural engineering. And I was given a choice to choose which one I was most interested in, and I did to which individual within the department. And structure stood out because it mixes between all the different members of the team. One season you could be responsible for something composite. The other season you could be responsible for something metallic. One season you could be responsible for the suspension component, the next an aero component, or a cooling component. And I thought this is the best way to get a well-rounded experience of an entire race vehicle as fast as possible as a young engineer. So some of the things I worked on in the placement year is all the most of the coolers on the car, and thankfully Franco could crash the car for us so I could make it on TV. So you can see it on the top. And then also a lot of inboard suspension components. So there you can see the front nose showing a little anti-roll bar sticking out. I'll let you guys try to figure out how that works in that orientation. And yeah, and just really fell in love with the creative side and the concept stage of developing technologies for the car and really being encouraged to be out of the box. And I don't know, something about the way at Williams that engineers in meetings, in conversations to really influence the car really just empowered me. And I just became as creative as I'd ever been before and being able to think of new ideas. I think we're likely the largest Formula Student team in the world. So that was very rewarding. And yeah, I invite you to ask any questions about Formula Student and FSAE and your experiences and how to get the most out of it in the Q&A at the end. So then I've been graduated for just about 1 year now from university. And yeah, back at Williams in the structural engineering department. And some of the cool things I've been getting to work on as a graduate. My first project that I got assigned when I stepped back in the door was the rear uprights. And it's a very daunting thing because it was I love suspension. And it was the bucket list responsibility I had that I wanted to do by the end of my career. And here I am walking on the first day and I get assigned something like that. Lots of topology optimization and things like that. And just the biggest responsibility you can have in my department as a single individual. Anything bigger requires multiple engineers to work on it at once. And yeah, great experience and got on the car. And then after that, I became the structural engineer responsible for the rear wing. So that's what I do currently. And it was pretty odd getting assigned that within half a year of graduating. And especially all the senior engineers that I knew that had been responsible for it before me. So, you know, in Formula One, you don't often get a lot of praise for doing a good job. That's the expectation. So getting assigned something like that is really the form of praise that you get. And that was really rewarding. And it's gone well so far. There's some cool projects and things like the Monaco spec that I encourage you guys to ask about, have some cool stories about that too. And get some trackside experiences as well. Got to go to Pirelli test at Silverstone recently and look after anything that might be causing structural issues on the car and trying to address them, any faults trackside. And yeah, the drivers are around a lot, which is awesome. Very welcoming and easy to speak to. So yeah, that's my experience really. And yeah, I look forward to answering any of the questions you guys might have later on.
Thank you both for sharing your stories. I just have a few questions before we open it up to the audience. I do see some Williams fans out there, so I'm sure you're going to get some great questions from them. I'm going to start with you, Prescott. You've had the unique experience to be both a driver before transitioning into the engineering role. Are there any skills or experiences that you felt like you gained that put you ahead in the role that you have now?
Yeah, absolutely. Can you guys hear me okay? How's that? Better? Okay, cool. Yeah, absolutely. I definitely say that my driving experience helped me more as an engineer than my engineer experience as a driver, thankfully, given the career I've chosen. And yeah, some of the ways that is really being able to visualize the way loads are going into the race car. Really being able to visualize what's a realistic scenario, what's a realistic load case to account for. Knowing what tracks the driver's likely going to be using curbs, what tracks are likely not going to be using curbs, and what combination of inertia and speed scenarios are realistic. What kind of scenarios are drivers really caring about, the mechanical balance versus the aero balance, and what parts of the track. And one of the projects I could think of would exhibit nonlinear behavior at different speeds, nonlinear behavior between left and right as well. So really trying to, from a structural side, decide, okay, what parameters does the driver in the loop simulator team need to know to be able to simulate this and get the driver feedback to say yes or no, this is a good thing to put on the car or not. And so that was helpful for that reason. And then also getting to go into the DIL, so we call the driver in the loop simulator, and have the driver be in the car, feeling things. I'd have multiple different maps for different types of ARB arrangements, and based on the driver feedback as they're driving laps around Barcelona, know which map to put on the car because of the feedback that they're giving us. Whereas the other engineers there didn't know what map 1, map 2, map 3 did because I made them like that day. So yeah, and really helped drive that sort of decision making. So that was an example of where it helped the most, I'd say.
Thank you. Rami, you also shared that you had a lot of unique experiences and challenges that you said yes to that ended up leading you to the role that you have now. I feel like there's a lot of people in this room feel like they also would have a similar path that eventually would lead them to get into motorsports. What advice do you give to those people who might feel like they're not on the path they want to be right now, but one day aspire to be in motorsport engineering?
Can you guys hear me? So what I'd say is, first and foremost, focus on being a good engineer and understanding kind of what area of engineering, or even beyond engineering, what area of the business you're interested in, and trying to be the best person that you can for that. Especially, I think, coming from the US, you always had that barrier of the immigration and getting the visa. But the thing is, F1 teams nowadays they're looking for the best engineers. So to give you an idea, like in our group, we have people who never worked in F1 before. They worked in heat transfer companies, but they're the best at what they do. And like there are other examples of this where people come from just totally different fields. Like there's a very famous F1 engineer named William Towett. His background's in biology, but he ended up being the head of aero at, I think, Ferrari. So again, it comes back to how do you look at problems? How do you solve them? How do you go through that step-by-step process? How do you break down something that's really complex into something that's more bite-sized and simple? And knowing that you're never going to have perfect data, but you still have to make a decision. So just trying to hone in on those skills, and also just being resilient. Like I tell a lot of students like I got my start in F1 10 years after I finished my undergrad. So it was a very painful 10 years, but along the process, I learned so many things that I think if I had where I was at after as an undergrad, if I had gone straight in, I would not be able to do the job I do today. So I hope that helps.
You both talked about making decisions and solving problems. Inherently, that's what you do as engineers, right? Something that I thought would be posed that was very interesting. Several years ago, F1 introduced the cost cap. Having infinite resources now, do you feel like that has made you more creative or limited your ability to be creative? And that's to you both.
I guess I can start. Yeah, it certainly changed the way we work. Something that we're responsible for in the structures department is deciding how long parts are allowed to last on the car, their fatigue life, and service lives. And before, you really would try to make something on the edge light enough to get on the car. If you had to replace bolts every single Grand Prix, you'd do it. And now that's changed. A lot of the projects that we worked on when the cost cap was first introduced or nearly first introduced was, okay, how do we extend the life of something without putting too much more mass on the car? And that's like not really a question that would have been asked before that. And so that was very interesting. Other than that, a lot of really in-depth decision making and data collection and approvals of any project proposals. So while coming up with all the ideas you possibly can to make the car faster is encouraged, not every single one's going to get on the car, and certainly less than there used to be, because every project has to go through a rigorous decision process, whether it's worth the money to spend for that level of performance. And every project is compared to each other for that reason. So that's changed a lot. In terms of whether it allows us to be more or less creative, I'd say the difficult thing is that it can accidentally prevent certain ideas from getting voiced because of assumptions that are made of whether something is going to be expensive to do or not. So the best way to go about that is just ignore the cost side of it and just say the idea anyway and let the decision process take its course. But people also are time constrained as well, and sometimes investigating whether an idea is worth doing takes time and engineering resource to find out. And sometimes there could be good ideas that are never discovered or tried or tested or investigated because of those sorts of early on assumptions.
Yeah, I think presentation very important in the sense of long time ago we could just test everything, and if you look to say Ferrari Schumacher years, they had an entire test team running 3 cars all around the world. You can't do that nowadays in Cosmic World. So it focuses you to do a lot more simulation, so a lot of like structural work, but also system level simulation, CFD, and also kind of try and think more from first principles, because you can't just guess anymore, because money is so valuable. So really trying to think about what is the problem I'm trying to solve here, which is not always clear, but that answers the question a little bit.
Thank you. Before we open it up to the audience, we do have a lot of students in the room tonight. If you could give them one piece of advice that they could get out of their student experience with SAE beyond just simply building the car, what would it be?
It's going to sound super cliche, but learning to work with others. Something that was a big challenge in such a large team like Brookes Racing is, people really throughout the project. And that's something that's unique to what FSAE and Formula Student offers students, is being involved from the concept phase all the way to delivery, manufacture, testing. And it's easy to want to have a hold of all of that, but really in the real world, that doesn't quite exist. So one, you got to try to get that experience while you can, but you've got to learn how to get others involved in the process and extract the most from each other. And really trying to get involved in projects where there are multiple people. If you're a senior member, try to get young members involved in your project and try to learn how to extract the most from a young member, because one day you're going to be a senior engineer at a company somewhere and trying to extract the most from a graduate that came into your team or your company. And this is the time to learn it.
To add to that, I'd say always remember that a car is a trade. So if you want the best aero package, what are you giving up for that best aero package? If you want the most power out of your engine, what are you giving up? And the fastest car is the one that balances those trades in the best way. And then the second one, more professional advice. If you have a chance, like go to the SAE World Conference in Michigan. Really great experience, and you can learn a lot from some of the breakout sessions. I know the aero one is really interesting. There was a really interesting heated debate on CFD, and it just opened my eyes up to that world. So
choose to look at Oxford Brookes in particular?
I think what people forget is that simulation can also help us build better experiment. Let's build a better experiment. And really, we need to stop thinking of them as two separate entities, but two complement entities. And what can we use from either to inevitably build a better, faster car or really anything?
So my question is basically like when you're iterating on like a part that you're gonna ship to the car, pretty much. How do you like? What is the process of and timeline of getting that last like I don't know last detail? Like how do you? It's not just like guess and check. Like how do you like figure that out? My best. Well, like take arrow for example, like say like a leading edge of like some kind of wing. How do you get that like last little tweak to the left and right? Like I don't know.
The question is, how do you finalize the absolute last detail of a part before you consider it finished?
Sure. Yeah, so great question. And it's a question we're always battling. What is worth doing? How small of an increment is worth looking at? And in Formula One, everything is really time constrained. So you can continue to find performance from something, but you always got to get it on the car. And the race date is not going to change. So you've got to maximize the amount of time you have in the development phase to get as much performance out of it. But in the cost cap era, there's always the trade of, okay, how many minutes of my time am I spending for what amount of performance on the car? And if that trade for you as an individual is not worth it, you should probably be looking at finding performance on the next part you're going to work on and get that part out early. Because that's how you're going to make the fastest car possible. It's very tempting to want to maximize the time you're allotted until your planned, release date for that component to try to get every last little tenth of a gram out of it. But you have to recognize, nobody's going to tell you this, but you have to recognize, okay, yeah, this is not worth working on anymore. I have a working solution. My next project is going to be X. And my first few iterations of the next day or two that I'm going to work on that early are going to find, let's say 3 milliseconds per hour versus, half a millisecond per hour if I continue working on this thing. So that's the one thing that you have to debate and know where to stop. But then how do you decide like what changes to make by those last few iterations? If you've gotten to the point where you're making really small changes, you should know how you got to the solution you have in front of you right then. And oftentimes it's continuing to go in the same direction. So you really should first question how you got to the iteration you currently have. Why did you go down the path to get to the current iteration you have from what you had previously? Trying to understand the fundamentals of what is making that more performant. Why are you looking at this iteration and not the other one that you could have gone for? And then that should influence your decision for what the small change to tune it to be correct, or find a little bit extra within your limitations should be.
First of all, excellent presentations from both of you, very, very young men. I have a question that basically is going to ask you to, what would you change? On day one, when you become the CEO or the chief engineer at Williams or Rami Racing or Prescott Motorsport, on day one of an F1 team, when you take over, we're a bunch of race fans, and we've got a lot of engineering talent in this room, but we're in a racing museum. So I was a race fan. On day one, you have a mid-pack car. What are you going to ask your engineers to focus on to get your car towards the front? And I'm hoping you guys have different answers because I'm going to process that Would it be tires? Would it be structural? Would it be aerodynamics? Where would you guys individually, when you're running your own F1 team, where would you have your engineers focus their attention to move your car towards the front? Thank you.
Great question. I'm going to summarize that. The question was, day one, you are chief engineer of insert any mid-pack racing team.
Being killed in the decision chain, and why aren't they getting delivered to the car? What level in the management structure is making the conservative decisions? We need to recognize where that is. Is it right near the base of senior engineering down that's doing the actual work, that's too shy to come up with these ideas? Is it the heads of departments that are killing the ideas because of job security, and they're the ones that are going to have to be responsible for something being a waste of time or failing on the car? Are they missing security? Is it happening even higher up in the chief engineering level? Or is it happening at the team principal level that's encouraging things because they're afraid of disappointing investors and people owning the team? And recognizing that, where is it happening? And then speaking to those people and trying to figure out what the reason why the conservative decisions are being made are. What's the reason behind that? And then really trying to then act on that. Trying to resolve whether it's job security, trying to resolve whether it's because people really just aren't looking through the rules and trying to find gray areas enough. Is it time? What is it? And then trying to address that. That's what I would do.
Okay, we're going to take two more questions. Let's go all the way to the back.
So
I think you're going to understand it better than me, but how do you make trade-offs and make decisions to effectively make the most efficient usage of your tools?
so going to answer your question with another question, which is really annoying. But when you say multimodal, do you mean like mode shapes, like in deflection, like the different modes, or? Yeah. Yep. Yep. Okay, I think so. We predominantly work with like 1D simulation, so probably the most stripped back form of that, and in general, at least with the heat transfer stuff. So I haven't done a lot of suspension and aero coupling, to be fair, but I know with heat transfer stuff, we always try the bigger picture you get, the more 1D and smaller dimension we work with, and then when you want to go into very complex problems, that's when you go into, I guess, like say like conjugate heat transfer or something much more high fidelity simulation. So I don't know if that really answers the question, but primarily, at least as I've seen it, the more coupled your problems are and the more bigger of a system you're looking at, the smaller in scope you go dimensionally. So more 1D simulation. And I think that's where 1D simulation is really powerful.
All right, last question. Yes.
So, first question for you guys. Between the eagerness for a challenge and the desire for simplicity, where would you guys personally
Go ahead. Okay, I'll go first. So I'll answer this in the context of former student from SIE. A lot of you guys will know that a lot of times, a really good, reliable race car is a simple one. And a reliable race car usually allows you to test the most and extract the most performance by the time you get to competition, even if it's not theoretically the fastest platform out there. But on the other side, the technical challenge, the complexity, is often where you get the most learning. But it may not be the most rewarding when you come to competition because for some reason or another, the car didn't work because it's so complex. So yeah, I'd say for me, I err on the side of simplicity. A lot of the reason for that is because I guess I value the learning that you get from testing your system. And so the simpler it is, the sooner you can get to that stage. And I find that part of the experience the most fulfilling. So that's, yeah, for me.
It's a really good question because like both, I tend to err towards more like complexity and interesting, but life has taught me that you can't, as Prescott was saying, to do complex challenges, you need time. And that's more of a long-term thing. To do like err on the simple side, like that's the there and now. And I think you need a little bit of both where you start with something conservative for now with the eyesight of, oh, this thing looks interesting. It's complex, but it could have a huge potential. This is going to be an R&D item. And you keep, if that makes sense.
For your fantastic questions. Thank you, Prescott. Thank you, Rami, for your time. I want to say before we break, in Women in Motorsports North America, we have a saying, once you have the door open, hold the door open, and then pull the next person through. So we have 30 minutes still of the museum being open. Please enjoy it, but please take time to get to know people in this space, network, ask your questions that were not able to be asked right now, but use this time to make a difference in someone's career. Thank you all tonight, and am I passing it back to you, our MC?
Vintage 1981 Allen.
Thank you so much.
So there's probably no one at your the shop who's old enough to remember that. So you can either take it back or give it to your parents for safekeeping here. So
Thank you much.
Anyway, thank you.
Dean, I will say we had a guy in the aero department who retired 2 years ago. He had been there since 1983. He does very rarely, because I think he lives in Spain now. But I have seen him at 1 or 2 town halls.
Patrick Head came to Formula SAE in Michigan in the mid-90s because he had, I think, a nephew on a team. He was just there as a spectator to observe. But some cool stuff. Anyway, please there's handouts for SAE, WIMNA, Motor Press Guild. Help spread the word. We like to do these fun things and spread the word to companies who are looking to hire. You know, we want to make this be very productive for companies and people who are looking for career opportunities, not just engineering. So, you know, I know at least one person in the room next month might want to announce something for some non-technical positions, but you know, let's grow the community. And like Emily said, let's help each other. So thank you very much for coming. Enjoy the museum. There may still be hot dogs left. Okay, 17 hot dogs left. Here again, all this, and a big shout out to the Lions Club. Also thanks to Miles Regan, our photographer, TJ Keon, who does the video. It's all a volunteer team effort. So if you'd like to get involved, talk to Dr. Bach, myself, Vanessa, anyone. We're open to ideas, but not just ideas. You need to say, I can help with that idea. So thank you very much. Yeah.
How you like being back in the States?
Thank you so much.
Good. Yeah.
It is.
So that was the first world championship for Williams.
Yeah, this means a lot.
Well, I appreciate you taking the time. Presentation was great. So, yeah, let's put this. Oh, okay. Oh, he wants to do a shot. Here, you can hold
I'd say by now it does. I
I
keep pitching myself.
Hang on. Miles wants a shot here. You can take name tags off. They look better off photos.
Back in the States, or you think you're going to be out there for that?